Dear students, in this video I will discuss very different forms of equation of line. Before discussing this topic, let us discuss slope of a line. As you know, the concept of slope of a line, the angle which it makes if you have a line L, and if it makes an angle theta with the positive direction of x-axis, then its slope n is equal to tan theta. So the slope of a line is the angle made by a line in the anti-clockwise direction with the positive x-axis. Now let us discuss the slope of a line in terms of coordinates of 2 points. If a line passes through 2 points x dash y dash, passes through 2 points having the coordinates x1 comma y1 and x2 comma y2, and if it makes angle theta with x-axis, then its slope can be calculated using these coordinates. So from the point, let this point be A, B, and from point B drop a perpendicular on x-axis BN. From the point A drop a perpendicular on x-axis BN, and then from the point A draw a line parallel to x-axis, that is AP is perpendicular to BM. Now angle BAP is equal to this angle theta. This point A has the coordinates x1 comma y1. These two angles are angle BAP is equal to angle BQM. Angle BAP is equal to angle BQM. These are the corresponding angles, so this is also equal to theta. Now let us consider in the right triangle BPA. In right triangle BPA, tan theta, m is equal to tan theta. So this tan theta can be calculated from this triangle BPA. Tan theta is equal to BP upon AP, and BP is equal to BM minus MP. This point, up to this point, distance is y1 and this distance is y2. So we can write BP is equal to BM minus PM upon AP. AP is equal to MN. Because this is a rectangle, APMN is a rectangle. So PM is equal to AN, that is the y coordinate of point A, which is equal to y1. This is a rectangle, so this is y1, this is also y1. Now MN is equal to OM minus ON. OM is the x coordinate of point B, that is this distance is x2, and up to n, this distance is x1. So mn is equal to OM minus ON, that is putting the values here, y2 minus y1 upon x2 minus x1. So in terms of the coordinates of 2 points, we can find the slope of a line using the coordinates. So the slope of the line is equal to the difference of the y coordinate divided by the difference of the x coordinate. Now you have understood the concept of the slope. In terms of angle, m is equal to tan theta, and in terms of coordinates of 2 points, m is equal to difference of y coordinates divided by difference of x coordinate. Now let us understand the various forms of the equation one by one. So first form is slope intercept form. In this form, the equation is expressed in terms of slope and y-intercept. First I am discussing slope and y-intercept, and then slope and x-intercept. So if a line has the slope m and it makes an intercept of length c on y-axis, then this point where it cuts the y-axis has the coordinates. X coordinate is 0 on the y-axis and this distance is c, so it has the coordinates 0, c. Now as I told you, slope of a line is the difference of y coordinate divided by difference of x coordinate. If we want to find the equation of the line, let us take a variable point which can move on the line. Let its coordinate be here x comma y. Any point on the line be x comma y. Let this point be, let us take this point as A and this point as B. Now slope of m is equal to tan theta is equal to slope of AB and slope of AB, and I told you slope of a line in terms of two coordinates of 2 points is the difference of y coordinate divided by difference of x coordinate. So I can write this slope m is equal to the difference of y coordinates, that is A point has the y coordinate as c and B point has the y coordinate as y. So the difference of y minus c upon difference of x coordinate, that is x minus 0. So this implies that m is equal to y minus c upon x, and if you cross multiply, then y minus c is equal to mx, or y is equal to mx plus c. So this form is known as slope intercept form, because here we have expressed the equation in terms of m and c, where m is the slope and c is the y-intercept. Now if this line passes through the origin, then a special case. If line passes through origin, then c is equal to 0. if this line passes through the origin, then C y-intercept will be 0, and in that case the equation of the line will be equal to y equal to mx. Putting C equal to 0 here, so y is equal to mx. So y is equal to mx is the equation of a straight line which passes through the origin, and if it makes intercept C on y-axis, then the equation of the line is y is equal to mx plus C. If the line makes an intercept D of length D on the x-axis. In the earlier case, we discussed the situation in which the line makes an intercept C on y-axis. If the line makes an intercept D on x-axis, then in that case, again, using the same concept, slope of the line is m, and the intercept, that is the length from the origin to the point where it cuts the y-axis, this is the x-intercept. OA is the x-intercept. Length OA is called x-intercept, and slope of line is m. Now this point A has the coordinates d, 0. Because if you have a point, any point on x-axis, then its y coordinate is 0, d, 0. And let us consider a variable point here. Let this point be B here, and having the coordinate x, y. We find the equation of a line in terms of the variable point x, y. So slope of AB is equal to difference of y coordinates, that is using the formula y2 minus y1 upon x2 minus x1, and slope of the line is m. M is equal to y2 minus y1, that is y minus 0 upon x minus d. So we get y is equal to m into x minus d. So if a line makes an intercept D on the x-axis, then and has the slope m, then its equation takes the form y is equal to m into x minus d. Y is equal to m into x minus d. Now the second form is slope point form. From the form it is clear that slope will be involved and point will be involved. So let the slope of this line be m. Slope of line is m, and this line is passing through the point x1, y1. And having the slope m. Now to form the equation, let us consider a variable point on the line which has the coordinates x, y. Let a point P be here, or this is A and this is P. x1, P is x, y. Now again using the same concept, how we find the slope? Slope of a line is equal to the difference of y coordinates divided by difference of x coordinate. So using that formula, m is equal to y2 minus y1 upon x2 minus x1. M is equal to y2 minus y1. This is the elected, let us consider this as x2 y2 and this as x1 y1. So y minus y1 upon x minus x1, taking this as x2 y2. So y minus y1, this implies that y minus y1 is equal to by cross multiplication m into x minus x1. So this form is known as slope point form. Third form is 2-point form. So let us draw a line which passes through 2 points. A point has the coordinates x1, y1. B point has the coordinates x2, y2. Let us consider a variable point P. Again using the same concept which we used in the previous derivations. Slope of line AB is equal to slope of line AP because they are in a straight line, so same inclination, same slope, that is, and slope of AB is equal to slope of AP. Now you know how we define the slope. Slope is the if a line passes through 2 points, then slope is the difference of y coordinates divided by difference of x coordinates. So now difference of y coordinates A and B point, so y2 minus y1 upon x2 minus difference of x coordinates. This is equal to slope of AP, difference of y coordinate, that is y minus y1 upon x minus x1. If we cross multiply, then y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. This form where 2 points are involved is known as 2-point formula. Next, let us discuss the fourth form, which is known as intercept form. Intercepts, first let us discuss the intercepts. If we draw a line, then it intersects x-axis as well as y-axis. So this OA length is called x-intercept. Length of origin from origin to the point where it cuts the x-axis is called x-intercept. Let it be A. OA is x-intercept. And let this x-intercept OA be equal to A. And the cut segment of line which it cuts on the y-axis, its distance from the origin to the, let this point be B here, and this length be B, small b, then OB is called y-intercept. Let OB is equal to small b. So we will find the equation of the line in terms of A and B, that is the x length and the y length. Point A will be having the coordinates, will have the coordinates A, 0 because it lies on the x axis, so y coordinate is 0, and point B lies on y axis, so its x coordinate is 0, so it has the coordinate 0, b. Now we can find the equation of this line using the concept of slope. Let there be a point P having the coordinate x, y. Now slope of AB is equal to slope of AP. AP and AB are the same line segments, so they have the same inclination, that is their slope are equal. So slope of AB you can find using the concept of difference of y coordinate, that is b minus 0 upon the difference of x coordinate, that is 0 minus a, using the formula of difference of y coordinate divided by difference of x coordinate. This is equal to, so right here The difference of y coordinates, that is y minus 0 upon x minus a. So we get y upon x minus a. If we cross multiply, then bx minus ab is equal to minus ay. Keeping the variables x and y in one side, bx plus ay is equal to ab. Now dividing both sides by ab, bx, or you can write this as bx upon plus ay upon ab is equal to 1. If you separately solve this, bx upon ab, that is b cancelled, x upon a plus y upon b is equal to 1. This form is known as intercepts form. Fifth form, normal form or perpendicular form. If a line is drawn and a perpendicular from origin is dropped on it, which is having the length p, and this perpendicular or normal makes an angle alpha with the positive direction of x-axis, then the equation in the form of p and alpha and x and y is called normal form or perpendicular form. For this, let us take this point where it cuts the x-axis as A and this point as B. Now we will use the formula of intercept form, which is x upon A plus y upon B is equal to 1. This length, let us take this length as A and the y-intercept as B. Let this point where the perpendicular cuts this line through A and B be M. Now let us consider the right triangle OMA. Since OM is perpendicular to AB, there is right triangle OMA. Side opposite to 90 degrees hypotenuse, that is OA, and side adjacent to the this hypotenuse and containing this angle, that is OM, is the base. OM is base, so cos alpha is equal to OM upon OA. OM is P upon OA is A. So we can cross multiply here. A cos alpha is equal to P, or cos alpha A is equal to P upon cos alpha. This is number 1. Now, how to find OB? This angle is alpha, this is 90 degree, this angle is 90 minus alpha, and this angle is 90 minus alpha, the whole angle is 90, so this angle, that is angle B, will be alpha. Now we will consider the right triangle OMB. In right triangle OMB, for this angle, OM is the perpendicular and OB is the hypotenuse, because it is opposite to 90 degree angle. So this is the hypotenuse and perpendicular. So we will consider sine alpha here. Sine alpha is equal to, for this angle, perpendicular is OM upon hypotenuse is OB. OM upon OB. OM is equal to P upon OB. OB is equal to small b. So V sine alpha is equal to P, or we can say b is equal to p upon sin alpha. This is number 2. Putting these values in this equation, x upon a plus y upon b is equal to 1. X upon a, value of a we have calculated, p upon cos alpha, plus y upon b, value of b is p upon sin alpha, is equal to 1. Now if we take the reciprocal of the denominator, we get x cos alpha upon p plus y sin alpha upon p is equal to 1, or on further simplification, x cos alpha plus y sin alpha is equal to, this form is known as normal form or perpendicular form. So with this type, I conclude this session. Like and subscribe my channel for new videos, and in the next video I will discuss the other forms of the equation of line.